This video will cover moderate questions regarding the topic of implicit differentiation. The first question, differentiating both sides of equation with respect to x, we get y as a function of x. We can rewrite as d dx of x cubed plus d dx of 3x squared times y equals d dx of 4x times y squared plus d dx of 5. 3x squared plus, using the product rule, 6x times y plus 3x squared times d dx of y. Using the product rule again, 4 times y squared plus 4x times d dx of y squared plus 0. Then 3x squared plus 6xy plus 3x squared times d dx of y means 1 times dy dx equals 4y squared plus 4x times 2y times dy dx. 3x squared plus 6xy plus 3x squared dy dx equals 4y squared plus 8xy dy dx. Keep this one. 3x squared dy dx. Move this to the left. Minus 8xy times dy dx equals, keep 4y squared minus 3x squared minus 6xy. Then we can factor 3x squared minus 8xy times dy dx equals 4y squared minus 3x squared minus 6xy. Then the final answer dy dx equals 4y squared minus 3x squared minus 6xy over 3x squared minus 8xy. Question 2, we can rewrite as x equals y plus 5 to the power of 1 over 3. Then differentiating the equation implicitly with respect to x. Then 1 equals 1 over 3 y plus 5 to the power of minus 2 over 3. Then using the chain rule, d dx of y plus 5. 1 equals 1 over 3, back to the radical form, 1 over cube root of y plus 5 squared times, the first one is dy dx, then second one equals 0, then 1 equals 1 over 3 times cube root y plus 5, then squared, times dy dx. If you don't understand this part, please remember 1 over cube root x squared equals 1 over x to the power of 2 over 3 equals x to the power of minus 2 over 3. 1 over cube root of x then squared equals 1 over x to the power of 1 over 3 squared 1 over x to the power of 2 over 3. We have the same answer. Back to the original. Cube root y plus 5 equals x. Then 1 equals 1 over 3x squared times dy dx. Then dy dx equals 3x squared. Or cube on each side. Then we get x cubed equals y plus 5. Then d dx of x cubed equals d dx of y plus 5. 3x squared equals dy dx. We have the same answer. Question 3, we can rewrite as x times y to the power of 1 over 2 equals x to the power of 4 plus x squared times y squared. Differentiating the equation implicitly with respect to x, using the chain rule, 1 over 2 times x times y to the power of 1 over 2 times d dx of x times y equals d dx of x to the power of 4 plus d dx of x squared times y squared plus x squared times d dx of y squared. 1 over 2 times 1 over square root of x times y times, using the product rule, d dx of x equals 1 times y plus x times d dx of y means dy dx equals 4x cubed plus this one is 2x times y squared plus x squared times d dx of y squared means 2y times dy dx. Then 1 over 2 square root of xy times y plus x times dy dx equals 4x cubed plus 2xy squared plus 2x squared y times dy dx. Then times 2 square root of xy on each side. The first one is y plus x times dy dx equals 8x cubed square root of xy plus 4xy squared square root of xy plus 4x squared y square root of xy times dy dx. We can rewrite as x times dy dx. Move this one to the left. Minus 4x squared y square root of xy dy dx equals, keep this one, 8x cubed square root of xy plus 4xy squared square root of xy. Move y to the right, minus y. Then we can factor x minus 4x squared y square root of xy times dy dx equals 8x cubed square root of xy plus 4xy squared square root of xy minus y. Now dy dx equals 8x cubed square root of xy plus 4xy squared square root of xy minus y over x minus 4x squared y square root of xy. Question 4. d dx of the left hand side equals d dx of the right hand side. Then 3x squared plus 3y squared times dy dx equals cosine x times y times d dx of x times y. Then 3x squared plus 3y squared times dy dx equals cosine xy times, using the product rule, d dx of x equals 1 times keep the second one plus keep the first one, then d dx of y equals dy dx. Then 3x squared plus 3y squared times dy dx equals, expand y times cosine xy plus second one x times cosine xy times dy dx. 3y squared dy dx, move this one to the left, minus x cosine xy times dy dx equals, keep this one, y cosine xy minus 3x squared. Then we can factor 3y squared minus x cosine x times y, then dy dx equals y cosine x times y minus 3x squared. Final answer, dy dx equals y cosine xy minus 3x squared over 3y squared minus x cosine xy. Question 5. d dx of left hand side equals d dx of right hand side. Then we can rewrite as d dx of y squared times sine x cubed plus, keep the first one, times d dx of sine x cubed equals, using the product rule again, d dx of x squared times sine y cubed plus x squared times d dx of sine y cubed. The first one, using the chain rule, 2y times dy dx times sine x cubed plus y squared times d dx of sine x cubed equals cosine x cubed times d dx of x cubed equals, this one is 2x, then keep the second one, sine y cubed plus x squared times d dx of sine y cubed means cosine y cubed times d dx of y cubed. Then 2y sine x cubed times dy dx plus y squared cosine x cubed times d dx of x cubed equals 3x squared equals 2x sine y cubed plus x squared cosine y cubed times d dx of y cubed equals, using the chain rule, 3y squared times dy dx. Keep this one, 2y sine x cubed dy dx, move this to the left, minus 3x squared y squared cosine y cubed times dy dx equals, keep this one, 2x sine y cubed, move this to the right, minus 3x squared y squared cosine x cubed. Then we can factor 2y sine x cubed minus 3x squared y squared cosine y cubed times dy dx equals, keep the right side, 2x sine y cubed minus 3x squared y squared cosine x cubed. The final answer, dy dx equals 2x sine y cubed minus 3x squared y squared cosine x cubed over 2y sine x cubed minus 3x squared y squared cosine y cubed. Question 6. Differentiating the equation implicitly with respect to x. So cosine x squared y cubed times d dx of x squared times y cubed equals secant squared x over y times d dx of x over y. Cosine x squared y cubed times, using the product rule, 2x times y cubed plus x squared times d dx of y cubed means 3y squared times dy dx equals secant squared x over y times, using the quotient rule, d dx of x means 1 times y minus x times dy dx over y squared times y squared on each side, then y squared cosine x squared y cubed times 2xy cubed plus 3x squared y squared dy dx equals secant squared x over y times y minus x times dy dx. Expand the first one, 2xy to the power of 5 cosine x squared y cubed plus the second one, 3x squared y to the power of 4 cosine x squared y cubed times dy dx equals, expand y times secant squared x over y minus the second one, x times secant squared x over y times dy dx. Keep this one, 3x squared y to the power of 4 cosine x squared y cubed times dy dx. Move this to the left, plus x secant squared x over y dy dx equals, keep this one, y secant squared x over y. Move this one to the right, minus 2x y to the power of 5 cosine x squared y cubed. Then you can factor 3x squared y to the power of 4 cosine x squared y cubed plus x secant squared x over y times dy dx equals, keep the right side, y secant squared x over y minus 2xy to the power of 5 cosine x squared y cubed. The final answer, dy dx equals y secant squared x over y minus 2x y to the power of 5 cosine x squared y cubed over 3x squared y to the power of 4 cosine x squared y cubed plus x secant squared x over y. This is the last one. d dx of x cubed times f of x squared plus d dx of x squared times f of x equals d dx of 5. Using the product rule, d dx of x cubed times f of x squared plus x cubed times d dx of f of x squared plus d dx of x squared times f of x plus x squared times d dx of f of x equals d dx of 5. The first one, 3x squared times f of x squared plus x cubed times 2f of x times f prime of x plus 2x times f of x plus x squared times f prime of x equals 0. If x equals 2, then 3 times 2 squared, which means 4, times f of 2 squared plus 2 cubed, which is 8, times 2 times f of 2 times f prime of 2 plus 2 times 2, which is 4, f of 2 plus 2 squared, which is 4, f prime of 2 equals 0. Then 12 times f of 2 equals minus 1, so minus 1 squared plus 16 times f of 2 equals minus 1 times f prime of 2 plus 4 times minus 1 plus 4 times f of 2 equals 0. Then 12 minus 16 f prime of 2 minus 4 plus 4 f prime of 2 equals 0. Then 12 minus 4 equals 8. Then minus 16 plus 4 equals minus 12. F of 2 equals 0. Minus 12 f prime of 2 equals minus 8. Then f prime of 2 equals minus 8 over minus 12, which is 2 over 3. I hope this video has been helpful. If you have any questions, leave them in a comment below, and I will address them in a future video. Thank you for watching. Please like and subscribe for more.